In this video, we're going to look at electron configurations in atoms. And like we saw in the previous chapter, electrons are in these things called orbitals. That is, they're just in these shapes around the atoms. And if we want to talk about which electrons are in which orbitals for a specific atom, that's called electron configuration. So here we have hydrogen, one atom. And if we say that hydrogen is in the ground state, or the lowest energy that it can be in, that one electron is in the 1s orbital. So you write out the orbital, and then in superscript you write out how many electrons are in that orbital. And the way we know which electrons are in which orbitals is by solving Schrodinger's equation. Now, we're not actually going to solve Schrodinger's equation, but that's how you do it. And Schrodinger's equation doesn't work for any atom that has more than one electron. You're missing some terms. But you can make some approximations, and you can see that electrons will be in different orbitals, like s, p, d, and f. And let's talk about how we put electrons in these orbitals. And to do that, we need to talk about spin and energy splitting in these different quantum levels. So spin. All spin it's a property that all electrons have. And all electrons have the same amount of spin. If you want to think about electrons physically spinning, that's fine. They all go in the same speed, but they have this different directions. You can either spin up or you can spin down. If you want to think of it in directions, you could do clockwise and counterclockwise if that makes it easier for you. And so, like I said, you'll have two values of spin. You can be up or down, and we give that a quantum number ms. And the value is plus 1/2 or minus 1/2. So you can think of plus 1/2 as up or minus 1/2 as down. Now this is important because when we draw out how electrons are in orbitals, we draw it out like this in what's called an orbital diagram. If an electron has a spin up, we draw it with an up arrow, spin down with a down arrow. And there's something called the Pauli Exclusion principle, saying that no electrons can have the same four quantum numbers. So let's take a look at this orbital diagram with this chart. Here we're looking at two electrons. Both are in the n sublevel, the 0L sublevel, 0M sub L. But what is different is that one electron is spin up, one electron is spin down. And so since they have different quantum numbers, they can exist in the same atom. You could not draw the electrons both pointing up or both pointing down. You would be breaking the Pauli exclusion principle. You have to draw one with spin up and one with spin down. So if we look at the number of orbitals in a sublevel, we can determine how many electrons are in each sublevel. So the s sublevel has one orbital, so it's going to hold 2 electrons. P has 3 orbitals, 6 electrons. D has 5, so 10 electrons. F has 7, so 14. And we'll look at this in later videos, more in depth. So for these different sublevels, every electron in those sublevels have the same energy. So we say their energy is degenerate. That is, it's the same. However, if you look at different sublevels, if you have a lower quantum number, you are lower in energy. And so electrons want to be as low as energy as possible, so they want to go in the lower L quantum numbers first. So your s orbital is lower than your p orbital, which is lower than your d orbital, which is lower than your f orbital. Just talking about energy. And for these multi-electron atoms, that is atoms with more than one electron, the energies of these sublevels are split because electrons interact with each other because they're negatively charged, so they repel each other. They shield each other from seeing the nucleus, which is positively charged, And also they can penetrate each other, which means they can just switch between different sublevels. And we'll talk about all of these terms in later videos. But that's the end of this video, and see you in the next one.